My name is Jean-Pierre Trou, CEO of Mbue. I'm a licensed architect and interior designer with over 20 years experience in architecture and the construction industry.
And I'm Michael Wharton. Nice to meet you all. I got a background in aerospace engineering and computer science. Actually went to school here back in the day, but since then I've done a lot of work with remote sensing, some work in the aerospace industry, as well as artificial intelligence consulting. So excited to talk to you all.
Yeah, we're very excited for this talk about building a better world with AI, one architectural drawing at a time. So you guys excited? You guys want to start? Yeah. Let's do it. All right. Awesome. Well, let's talk a little bit about our industry. If you think about anything about the construction industry, the first word that comes to mind, what do you think it is? Just throw me something. Think about construction.
Permits.
Permits, yes. Terrible, right? Old? Yeah, archaic, very old. It's one of the oldest industries, Has much changed? Code, yes. We're going to address that. So, you're cheating. But yeah, if you look in the past, throughout history, really not much has changed from how we built back then and what we build now. But there has been a lot of progress in the advancements of technologies in adoption of new methods and technologies like 3D printing. And now we're seeing tremendous excitement about AI, especially in the architecture. In the architecture side, there's a tremendous excitement in generative design tools. So if you think about, anything that could help with the design process, right? So there's this excitement about, text-to-prompt image generators like Midjourney, DALL-E, and Stable Diffusion that creates these really amazing, evocative images of what architecture could be in the future. To the most practical application where we can see automation in feasibility studies, or be able to, you have a site and you have several parameters. Let's say you want to do a mixed-use project with multifamily and a portion of it is office. It brings you 100 to 1,000 different iterations of what you can put on that site. Or you want to move to a new office building and you can generate thousands of different test fits depending on your program for your business, right? You have X amount of conference rooms, private offices, open offices, and stuff like that. But the most critical aspect of our profession, the quality control, remains overlooked. Wait, quality control, is that the most important aspect of our profession? Can you imagine a world without quality control in construction? Right? So I'm looking at the image on the left in here. Somebody really took literal my plans and went and carved out a very precise cloud-shaped hole in the slab, right? So for those of you who don't get this joke, because this is a little bit tricky, clouds depict changes. So if I draw a cloud in a drawing, I'm telling you, hey, check it out, something has changed in here. So please don't carve a hole in my slab. I want to give up to the guy right in the middle. I mean, at what point somebody just said, hey, there's something wrong in here, man. It's like, are you sure the column's going here and this is where we egress? So imagine you are like in a fire or something, or like it's midnight and you want to get to your apartment. Somebody really waited a long time to bring that up to the architect and the builder. But my favorite one, I got to give it to the guy or whoever decided, hey, if this door doesn't open, don't worry, I'm going to cut it to shape perfectly, No, not switching the door or maybe like stuff, hey, do we get this thing wrong? Let's cut it to shape and see if that works. All right, so now you guys understand why quality control is important. The problem with quality control is that it lacks automation. So you have very experienced architects and builders and engineers sitting in conference rooms, reviewing hundreds and thousands of pages. It relies on human review. It's extremely painstaking and repetitive and time-consuming. I spend over 30 to 40% of my time sitting in a conference room reviewing hundreds of thousands of pages. I'm very good at what I do, but I still make mistakes, not like the ones that we saw, but I still do. And those mistakes has a significant downstream economic impact on the project. And those, if you think about it, like the AIA, which is the American Institute of Architects, did a study, and they found that the best set of construction documents out there has 95% accuracy. This is like the best, like being reviewed to the, to the single note in the drawing, 95%. That means on a $20 million, you can expect at least $1 million in mistakes. I was just trying to find a mistake in here in this room. I found that that diffuser right there is supposed to be flushed to that wall. So you see right there next to the exit sign. It happens all the time. All right, so how tedious can be this process, Jean-Pierre? Well, try to find 5 different things. I'm going to time you. 5 different things between these two. Seems that you found one already. You're smiling. Did you guys find at least one? Congratulations. You guys did it. Now let's try on 200 pages. 200 pages of technical drawings, multiple disciplines, paired with a Bible side of text that tells you everything from how you procure materials to how you submit those materials for approval, the warranties you need to provide. You name it. It's extremely tedious. And this is my product as an architect, engineer, or builder, right? This is my product because this is what carries all my liability. We use all this technology to build these amazing projects. And you think that, the product of the architect is those amazing images that you showed me on the first slide? That vision? No. My errors and emissions and insurance is this. This is what carries all my liability, and that's what I need to review. What has my stamp? So you have in this set of drawings different multiple disciplines. You have architecture, structural, mechanical, electrical, plumbing, MVP, landscape, civil, and a set of specifications that we talked about that. So now that you can understand why it's important and how tedious it is, why hasn't been automated and solved?
Well, I'll tell you, Jean-Pierre.
Let's do this. Tell me. Why hasn't?
Yeah, you're probably wondering why someone like me with a background in computer vision and deep learning's linking up with someone like Jean-Pierre here who's got decades of experience in architecture. It's because, the time's kind of ripe to solve this problem. You, with a little bit of training, can look at an architecture drawing with its friend that's a little bit newer, a little bit revised, and compare them. And perceptually, you can see what's different. You can see, are there more toilets now? Did a wall change dimension? Is the drawing view the exact same, but it actually moved across the page? It's pretty easy for you as a human to tell this, but it turns out until very recently, it's been very, very difficult to train computers to do something like this. Right. There are very small details that are difficult to catch, and it's especially challenging with architecture drawings because you're talking about sometimes tens of thousands of pixels just so, in width, just so you can have enough fine-grained detail that you can pick up really, really small details that turn out to have really large financial implications on the final build. Like I said, until very recently, it's been impossible to look at this and figure out perceptually what's going on in cases like this, but time's ripe. So, and I think a good way to illustrate this is to look. Right, yeah, let's switch. Let's do it.
Yeah, let's switch. We're tag teaming here.
A good way to illustrate this is just look at this comic. The date on this from XKCD, I'm sure y'all all have seen XKCD comics. It's 2014, and you might not be able to read the text, but essentially what's happening is there's an analyst and someone asking questions, and they're asking, hey, here's a photo. Can you tell me whether it was taken in a national park? And the analyst's like, sure, give me a few hours. I'm going to go look up a GIS database and figure out where this photo is taken, because that's probably what you would have done at the time. And then the next question is, can you tell me if it's a photo of a bird? And it's like, yeah, give me a research team and years to figure this out. Because at the time, that's what it would take to answer a question like that. And now all of you, I'm pretty sure, or at least some of you probably have iPhones, and you can go in your photos and just search with text, like find me photos of birds or photos of my friend or whatever, and it can actually do things like that. So technology's there, and it's very, very recent that we've had this in our toolkit.
This is how crazy fast have moved things.
Yeah, it is pretty wild. Back in '89, there was this research lab that I think was trying to detect digits of zip codes in those forms. I'm sure y'all have all filled out tax forms. It's tax season. You get the little boxes, you put in your zip code. They built a convolutional neural network, and it was handcrafted, painstaking, took a huge research team to figure out how to do this. And they were largely successful, but they also didn't have the accelerated compute that we find ourselves having today. And then in '98, Jan LeCun came up with this architecture that started to really, really hone that, and it started to use this algorithm called backpropagation, which I'm sure some of you have also heard of, that is used to train these convolutional neural networks with training data, instead of having humans having to craft exactly what all these numbers are that go into these networks. You know, sometimes you have thousands, millions, in the case of large language models, billions of parameters. You can't put all the humans in the world in there to craft this thing because it's just unfeasible. And then finally in 2012, this AlexNet came out, and that was the catalyst point where there's this historical benchmark called ImageNet, and that is this database of millions of images. They're all hand-labeled. You know, they have birds, do they have cars, or people in them? It's just these common classification labels, and the goal is to just get as accurate as possible. You build a model that takes in this an image and then predicts what's in it. And at this moment, when they released this architecture, it blew the original accuracy, I think it was top 5 accuracy, out of the water. It added something like 10 percentage points to the accuracy, and that is unheard of in our business. You know, it's a lot of times you have a team of people trying to just eke out an extra 0.5% here and there. And to see something like that is a pretty big step change. And then all of these innovations that have come out since then have always step change, kind of changed the state of the art. And we're now in this land now where we have the ability to, with computers, do perceptual tasks with, you know, without a human in the loop. So it's a pretty great time. And then, yeah, just in terms of what these things are doing under the hood, you know, you have, like I mentioned, anywhere between thousands to billions of parameters, and you present this network with a bunch of images with their associated labels. You say, you know, is it a bird? Is it a koala bear in this case? And then there are these special operations you do to look for, you know, at the higher levels of these networks, you're looking for really basic things like, you know, lines or certain kind of curves, or generally things that are very local and simple. And as you get deeper and deeper in these networks, you know, in some cases on these networks that are looking at humans, there's a single number inside there that'll tell you if they're wearing glasses or not. So it's really, really cool and really exciting. And we figured, you know, why the heck wouldn't we just take some of this technology and apply it to architecture?
Yeah. So how are we tackling this problem? So these are what I call the pillars of the quality control process. When I'm sitting and looking at a set of drawings, I'm looking from the perspective of graphics and annotations, making sure that every single drawing and detail is perfectly drawn and is coordinated, have enough information that I can depict what I'm trying to build. Change control, as design progresses, there's changes that constantly happen, and those changes have implications. Let's say I move a wall, I need to also make sure that the detail for that wall has been updated, and the cross-coordination aspect of it doesn't impact, you know, the mechanical in here, for example, right? So this relationship between this diffuser and the wall has some codependencies. So if I change the wall, there's a correlation and things, so that's cross-coordination. In this case, I'm giving you an example of the location of the structural element. The column is the same in the architecture drawings as is in the structural. And that's critical. You'll be surprised. There's a lot of issues on site because of that. To code compliance, somehow most of us have been familiar with some type of code, right? It changes the jurisdictions if you're doing a house remodel or anything. So it's extremely complex itself. And like I said, it depends on multiple jurisdictions and different types of codes. City of Austin has a plethora of codes that I have to review constantly, and they keep changing too. So, and then completeness check, to making sure that you have all the documentation in order to accurately price, permit, and build a project. So now that we understand, you know, all the different things, let's focus on one in particular. Let's focus on the change control aspect and how we're tackling that. Let's dive deeper into that.
That sounds good. And yeah, for the record, I've seen some of these code books that he mentions before. I've seen him slam one on the table. The whole room starts shaking. Everyone around turns around to see what happened. It's pretty bad. I don't envy your job.
No, that's the least part of the job that I like, but it's okay.
Yeah. But yeah, so like I mentioned classification tasks earlier, but there are all sorts of tools. There's a family of deep learning algorithms that really help us out here with the task at hand. And one of those is something called object detection. I'm sure you've all seen some videos where maybe you're watching a tennis match or a soccer match or football if you're from Peru.
Yeah, football.
Football. Sorry. Yeah,
yes.
there we go.
Football.
But yeah, you'll see a box that's drawn around players, around balls, and you see it kind of get tracked around. For a single frame, the task of drawing those boxes around the parts that you're really interested in, that's what object detection is. And it turns out that we can do that pretty reliably with these architecture drawings as well. Let's say you want to do something simple like count how many toilets are in a page. And maybe there are a ton of them, and for a human it would take a really long time. You could do one forward pass of a network that you've trained on documents,
right,
and you can answer that question in a matter of seconds or less. So, and this is a great example of some of the things that we might pull out or be interested in. If you can imagine looking at this and kind of piecing it apart, you have an original document and a revised one. There's so much detail on here to figure out as a human with your eyes that it would take you anywhere from minutes to, I don't know, days to figure out what are the actual important differences between these, what doesn't matter, what kind of action items do I need to take from that. And if we can use these techniques to enrich these documents and figure out, okay, where are the doors, where's the furniture, where are these appliances, you can piece it apart and kind of parse everything, and it sets you up for success when it comes to change control.
And it has semantic information, everything.
Yeah. Yeah, the context is actually very important. So not only are we looking for specific objects that we care about, but the relations between them are also really important, like the code compliance examples Jean-Pierre just told us about. But so with this box fidelity that we're looking for, maybe it's not enough. Maybe we need to actually know what regions are important to us. So for that, we would use something called semantic segmentation. This is a network here that's built on the same technologies that other one that I mentioned that kind of blew ImageNet out of the water. Same basic building blocks, just meant to serve a different purpose. But let's say we wanted to try to predict how much square footage is in this floor plan. And maybe some changes happened. There are a lot of changes. Structural elements changed. Floors changed. You want to just figure out something simple like, how much did the square footage change?
Right. That's
a really hard question to answer. Sometimes you need a team of people, but with semantic segmentation, we can do that. And here's just an example of the same kind of elements we were interested in before, but with the semantic segmentation layer applied. All sorts of different interesting use cases there. And then furthermore, we got these line segments that are also interesting. You might be wondering, that seems kind of silly. Why would you need line segments separated, and why would that matter? But it matters a lot, especially if you can classify them.
Right.
We're interested in actual structural elements of the document. Where are the doors? How big are they? How do they compare between versions? But also these annotations are really important. Maybe you want to figure out, there's a little, a group of text that has an arrow pointing to something. We want to figure out, what does that group of text mean from a natural language standpoint? Where are the line segments that are joining that relevant piece of text and something that it's pointing to? Maybe it's saying some specification about a material's changed. Right. A simple note like that, if we can understand it, might have tens of thousands to maybe even millions of dollars of impact on a design. And without a team of people that are analysts, that are experts, you just wouldn't know that really readily.
But just on that note alone is the ability to understand when you are making changes, what actually constitutes a change. So if you're looking at the node with a leader line and it starts to telling you, okay, I just moved the node graphically, the arrow is still pointing at the same location. Is that a change? So we're building intelligence to also interpret those changes the same way that I am looking at it in the drawing. So for me, that is not a change because the content hasn't changed, and also the point at the arrow hasn't changed the location. So it will make more sense once we go deeper. So table parsing.
Yeah, table parsing is another great one. It's routine that tables contain really important information that you need in context to figure out what the rest of the drawing means. I mean, maybe there's a certain code or something. I mean, check me on this, but maybe like you have a code that specifies a material,
Right.
and it's unique there, and you need this extra metadata to figure out why is that important, where does it apply, and if you can't parse these tables to figure out these key value pairs, these rows of information, figure out what these headings mean subjectively, then you're missing important information that prevents you from being able to do full change control here. And then just a couple, I mentioned this one inflection point. I would guess that this one in 2012 there is,
right here.
That's the one that corresponds to that AlexNet architecture we were talking about earlier. But back in the 90s, I'm sure you've all heard the term expert systems. Those heuristic rules-based models, if you've done any amount of software engineering, you know that you get some sort of baseline level of accuracy, and then you start to get to this territory of like whack-a-mole, where you make one change and it fixes something over here, but then something else breaks. And you're kind of at this asymptotic place where you can't make your thing better no matter how hard you try. Well, in computer vision specifically, these deep learning models allowed us to just break past that in 2012. And then more recently, the thing that allows us to have great things like GPT-4 and all these big large language models that you've heard about, underneath that is this technology called transformer models. And at first they didn't do very well with computer vision, but then vision transformers came on the scene, and now we do have them providing at least a little bit of extra value in addition to these baseline architectures that we've used for years now. So it's really just an exciting time to be part of this field.
So where we are on change control, we have applied all these techniques, and we are able to compare two set of drawings currently and identified everything that has changed, and to a level that is far superior and more accurate than a human. The problem is, it's very accurate, and it doesn't have that, understanding of what a change is a change or is not a change. So graphically, it takes everything, right? So then we're teaching it, to what are the set of rules that constitute a change. I use the example of the leader line. If it's still pointing at that chair, and it's saying it's a chair, and I haven't changed the text, it's not a change, right? No matter where that node is on the plan. But now we're also moving towards telling what has changed. So in this case, we're showing that there's been, remember the cloud that we saw originally? What a cloud means? Don't cut it, please. It's a revision, right? Okay, so that's a revision here. So I'm identifying what has changed in this drawing. So in here now we're telling, added a structural element, new concrete beam, 8 inches by 36 inches. And as the AI evolves, it's also identifying a potential code violation that we're not meeting a certain clearance. So in terms of installing any type of equipment that has some requirements from a clearance standpoint to code requirements, it will start to telling you as you actually review the drawings. And from a product evolution, right now, Mbue is a web-based application. We're using AI to instantly review your drawings. It's, if you know how to attach an attachment on an email, you know how to use Mbue. You just upload your first set of drawings and the one that you want to compare, and instantly you get a review. And we're moving towards the next, we're in beta right now. We have working with 10 customers, construction companies. We're testing this technology right now. It has a tremendous value because they're tracking changes as a part of their construction process. And we are introducing new models like natural language processing and reducing false positives right now. So in terms of false positives, what I mean is like, okay, we built a model that is very accurate, but is it smart enough that understands specifically what different changes you can find? So we are reducing that. We are identifying changes in text. You remember that set of specifications? That, just to give you an idea, I just did a office building in Burnett by the Torchy's Tacos there in North Burnett. 5209 Burnett it's called, or Victory Plaza. It's a 90,000 square foot office building. Took me a whole week to review those set of drawings that I showed you. That picture took me a whole week reviewing. And we can do that in the near future instantly. So it's a tremendous amount, saving tremendous amount of time and money and reducing significant amount of liability for architects and builders. So this is the amazing thing that we are building. And we'll be moving from the two document comparison because right now that's what we can do. We can identify from A and B what has changed. Going back to that image that you find super fast. I was super impressed how fast you found 5 different things on those images. We're doing that instantly. And we're moving to a single document review, which we don't need to see the previous version because we understand how the project evolves, and we can review the same way that you send me your drawings and I'm looking at it on a conference room. It can do it instantly. This is the application. Again, we're in beta right now. You upload a set of drawings and you get your comparison, and this is what you get. This is the output. So going back again, the clouds telling you everything that has been changed or that have been detected. You get a side-by-side comparison, so you see it from the previous version. You can tell that the drawing in here has been deleted and there's some information missing in here. There's a change on this table of content in here on your specification. And a column has been added as well. And then you get a diff file as well. So you can see side by side an overlaid simple diff file that you can easily identify what has graphically changed. So this is currently in beta. And thank you so much for the time.